ഹായ് ഫ്രണ്ട്സ്, ട്രേഡ്സ്മാൻ-ഇലക്ട്രോണിക്സിൻ്റെ KeralaPSCയുടെ 2022 നടന്ന കാറ്റഗറി നമ്പർ 754/2021 ക്വസ്റ്റ്യൻസും ഡീറ്റെയിൽ സൊല്യൂഷനുമാണ്. ഇത് മൂന്നാമത്തെ വീഡിയോ ആണ്. ക്വസ്റ്റ്യൻ നമ്പർ 34 വരെ ആദ്യ 2 വീഡിയോകളിൽ നമ്മൾ ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്. ക്വസ്റ്റ്യൻ നമ്പർ 35. All radios, tape recorders and televisions invariably use negative feedback in circuits for a function of. Answer is option B, automatic gain control. Negative feedback reduces gain of the amplifier. It also reduces distortion, noise and instability. This feedback increases bandwidth and improves input and output impedances. Due to these advantages, the negative feedback is frequently used in amplifiers. What is AGC? Automatic gain control is a system that controls the increase in the amplitude of an electrical signal from the original input to the amplified output automatically. AGC is a closed-loop feedback circuit present in radio receivers which helps to maintain a constant output irrespective of the input variation. In communication systems, the inclusion of AGC regulates the system output to a constant value, even if the input voltage decreases or increases. AGC is an algorithm that dynamically controls the gain of a signal to maintain a nominally constant output level. A typical example of application of AGC occurs while recording speech signals when the speaker is changing his or her distance from the microphone while speaking. Question number 36. How the maximum permissible collector base voltage that can be applied across collector base is? Answer is option A, VCB max, that is voltage across collector base maximum. The collector base breakdown voltage is a VCB, which is specified IC, that is collector current flows with the emitter terminal open. Since it is a reverse current across a junction, the IC exhibits a knee-shaped rise, increasing rapidly once breakdown occurs. Question number 37. Which type of package is used to transistors utilized for medium and power amplification? Answer is option D, plastic package with heat sinks. In electronics manufacturing, integrated circuit packaging is the final stage of semiconductor device fabrication, in which the blocks of semiconductor material is encapsulated in a supporting case that prevents physical damage or corrosion. The case known as a package. Low power transistor packaging is made of plastic material having a flat characteristic surface. Transistors with a medium or higher power are usually made of metal plastic packaging. A heatsink is a device used to transfer heat from a heat source to the surrounding environment. Heat transfer is achieved through a combination of conduction, convection, and to a lesser extent radiation. Question number 38. Which coding system for transistor type numbering system is followed by European standard? Answer is option D, Pro-Electron standard. There are many different ways of organizing a number scheme. In the early days of thermionic value, that is vacuum tube manufacture, each manufacturer gave a number to the types they manufactured. In this way, there were vast number of different numbers for devices, many of which are virtually identical. It soon became obvious that a more structured approach was required so that the same device could be brought regardless of the manufacturer. The same is true for semiconductor device and manufacturers. Independent numbering schemes are used for diodes, bipolar transistors and FETs. In fact, there are a few semiconductor numbering schemes in use. First one is a pro-electron numbering scheme. This diode, bipolar transistor and FET numbering scheme was originated in Europe and is widely used for transistors developed and manufactured here. Second one is JEDEC numbering scheme. This diode and transistor numbering scheme was originated in the USA and it is widely used for diodes transistors that originate from North America. JIS numbering scheme. This semiconductor device numbering scheme system was developed in Japan and can be seen on diodes, transistors and FETs that are made in Japan. Manufacturers' own schemes. There are some devices, particularly specialized bipolar transistors and some FETs, for which individual manufacturers may wish to retain all the manufacturing rights. They may not want to open up the specifications and manufacturing methods to others, as they are using a technique they have developed. In these and similar instances, manufacturers will use their own part numbering schemes that do not conform to the industry standard schemes. The aim of the industry standard numbering scheme is to allow for the identification and description of electronic components, and in this case, semiconductor devices including diodes, bipolar transistor and field effect transistors to have common electronic components and component numbering across several manufacturers. To achieve this, manufacturers register a definition for new electronic components with the relevant agency and then receive a new part number. Question number 39. The type code printed on a Zener is BZC9V1. The letter C indicates is answer is option C, 5% tolerance. The first letter of the symbol indicates the nature of the semiconductor material, that is A germanium, B silicon, C gallium arsenide, D photodiodes, R for compound, example cadmium sulfate. The second letter of any symbol indicates the device type and its function of the circuit. A diode, general purpose diode, B diode, variable capacitance, varactor diode, C transistor, audio frequency AF, low power transistor, D transistor, AF power transistor, E tunnel diode, F diode, high frequency low power transistor, G multiple devices, H magnetic sensitive devices, K Hall effect modulator, N photocoupler, P photodiode, bar radiation sensitive bar light detector diode, Q light emitting diode, radiation generating diode അല്ലെങ്കിൽ R switching device thyristor SCR or triac, S transistor low power switching transistor, T high power transistor, U power switching transistor, X diode or multiplier, Y power rectifier, Z Zener diode. The third letter does not have any particular significance. The letter is used to mention the specialized application of the diode. The second letter is N and then the first digit is 1 for diodes, 2 for transistors, 3 for 4 leader devices and so forth. But 4N and 5N are only used for optocouplers. ഇതെല്ലാം ഓർത്തിരിക്കാനുള്ള വഴികളാണ്. ഇതെല്ലാം മനസ്സിലാക്കുക, ഓർത്തിരിക്കുകയാണെങ്കിൽ എക്സാമുകൾക്ക് പെട്ടെന്ന് ആൻസർ ചെയ്യാൻ പറ്റും, കൺഫ്യൂഷനൊന്നും വരില്ല. An additional letter for Zener diodes will appear after the numbers. This letter denotes the tolerance of the Zener voltages. The following letters are used for denoting the tolerance of Zener diodes. A for plus or minus 1%, B for plus or minus 2%, C is for plus or minus 5% and D is for plus or minus 10%. Zener diodes have additional characters which will indicate the Zener voltage. Example 5V1 indicate 5.1 volt. What is JIS? That is Japanese Industrial Standard. These part numbers take the form digit 2 letters, sequential numbers, optional suffix. Digits are 1 for diodes, 2 for transistors and so forth. The letters indicate the type and intended application of that device according to the following code. SA PNB high frequency transistor, SB PNB audio frequency transistor, SC NPN high frequency transistor and SD NPN audio frequency transistor, SE diodes, SCF thyristors, SG P channel FET, SH UJT, SK N channel FET, SM triac, SQ LED, SR rectifier, SS signal diode, ST avalanche diode, SV vary cap, SZ Zener diode. Commonly 2 letters and 3 numbers and 3 letters and 2 numbers are used. 2 letters and 3 numbers, that is BF194, are used for consumer equipment or for entertainment purposes. whereas the device 3 letters and 2 numbers. Example BFX63 components are used for industrial or professional. Question number 40. JFET is commonly used as input amplifiers in voltmeters, oscilloscope and other measuring devices due to answer is option C, high input impedance. FET is a device that relies on the electric field to control the shape of the channel, therefore on the conduction of the channel, hence referred to as field effect transistor. FET is a unipolar transistor that involves only one type of charge carriers in its operation. Due to high input impedance, FET transistors are commonly used in and as input amplifiers in electronic voltmeters, oscilloscopes and other measuring devices. They also occupy little space, which makes them more efficient for other devices. What is JFET? The junction FET transistor is a form of FET that can be used to control a switch electrically. Between the source and the drain terminals, electrical energy travels through an active channel. The channel is strained and the electric current is switched off by supplying a reverse bias voltage to the gate terminal. It is classified as an N-channel JFET or a P-channel JFET depending on the channel. The source terminal connects the positive side of an N-channel JFET. In this N-channel JFET, the drain terminal has the largest potential compared to the gate. The connection created by the drain and gate terminal is in reverse bias. As a result, the depletion region around the drain is wider than the source. The majority of the charge carriers, which are electrons, flow from the terminal drain to the source. As the potential at the drain rises, the flow of carriers rises with it, and the flow of current also rises with it. Comparison between FET and MOSFET. Gate voltage controls the width of FET and modulates the channel conductivity of MOSFET. Types of FET is JFET, MESFET, HEMT. Types of MOSFET is NMOS and PMOS. Power consumption is lower than bipolar transistors. In MOSFET lower than bipolar transistor. Mode of operation എന്ന് പറയുന്നത് FET ഡിപ്ലീഷൻ മോഡാണ്. മോസ്ഫെറ്റിൽ ഡിപ്ലീഷനും ഉണ്ട്, എൻഹാൻസ്മെൻറ്റും ഉണ്ട്. പ്രൈസ് FETക്ക് ലെസ്സും മോസ്ഫെറ്റിന് മോറും ആണ്. ഇൻപുട്ട് ഇമ്പിഡൻസ് ഫെറ്റിന് കൂടുതലും മോറും FETക്ക് ഹൈയും മോസ്ഫെറ്റിന് വെരി ഹൈയുമാണ്. നോയ്സ് മോർ നോയ്സിയാണ് FET, ലെസ് നോയ്സിയാണ് മോസ്ഫെറ്റ്. നമ്പർ ഓഫ് ടെർമിനൽസ് FETക്ക് 3ഉം മോസ്ഫെറ്റിന് 4ഉം ആണ്. തെർമൽ സ്റ്റെബിലിറ്റി FETക്ക് ഗുഡും മോസ്ഫെറ്റ് ലെസ് സ്റ്റേബിളാണ്. കോംപ്ലക്സിറ്റി FET സിമ്പിളും മോസ്ഫെറ്റ് മോർ കോംപ്ലക്സുമാണ്. അപ്ലിക്കേഷൻസ് വരുന്നത് ആംപ്ലിഫയർ, സ്വിച്ചസ് ആൻഡ് RF ഡിവൈസ് ആണ് FET. മോസ്ഫെറ്റ് പവർ ആംപ്ലിഫയേഴ്സ്, ഡിജിറ്റൽ ലോജിക് ആൻഡ് ആംപ്ലിഫയേഴ്സ് ആണ്. ചാനൽ കണ്ടക്ടേഴ്സ് FETക്ക് മെജോറിറ്റി കാരിയേഴ്സ് ആൻഡ് മോസ്ഫെറ്റിന് അതും മെജോറിറ്റി കാരിയേഴ്സ് തന്നെയാണ്. ഗേറ്റ് സ്ട്രക്ചർ മെറ്റൽ ഓർ ഡോപ്ഡ് സെമി കണ്ടക്ടറാണ്. മെറ്റൽ ഓൺ ടോപ്പ് ഓഫ് എ തിൻ ഓക്സൈഡ് ലെയർ ആണ് മോസ്ഫെറ്റിൽ. What is the package type for JFET BFW10? Answer is option A, TO72. BFW10 N-channel depletion JFET 30 volt 20 milliampere is a TO72 package. It is composed of semiconductor materials usually with at least 3 terminals for connection to an external circuit. A voltage or current applied to one pair of the transistor's terminals controls the current through another pair of terminals. The TO72 is a type of metal can package for semiconductor devices. It is sealed hermetically to protect the device from environmental factors such as moisture and contaminants. The TO72 is commonly used in housing transistors. 42. What is the term stands for triac? Triode AC semiconductor. Triac is a bidirectional device accommodates signals traveling either direction through a single channel. Telephone lines are by operational requirements bidirectional. Triac allows the current in both direction and thus it is bidirectional. This is a symbol of triac and this is structure of triac. From here we can identify that it has 2 main terminals, that is MT1 and MT2, and also one gate terminal. In triacs, there will be a single gate control conduction in both the direction. A triac is equivalent to 2 SCRs joined together in parallel. Track available in high voltage ratings. Track is a 5-layer device. When a track is on, the current flowing between MT1 and MT is known as principal current. The minimum current which keeps the track conducting is called hypostatic or holding current. 44. The resistance between anode and cathode of SCR in quick test method is, answer is option B, infinite resistance. Question number 45. How many semiconductor layers are used in UJT fabrication? Answer is option B, 2. UJT has only two types of semiconductors. One is P-type and the other is N-type. UJT is also called a double base diode as it has two bases. This is the symbol of UJT. It has one emitter, one base, two bases, that is B1 and B2. UJT or PN transistor is a two-layer PN device with three terminals known as emitter, base 1 and base 2. UJT is fabricated on a lightly doped N-type silicon bar with ohmic contacts for two base terminals B1 and B2 at the top and lower ends of the bar. This is a structure of UJT. It exhibits negative resistance characteristics. That is, increase in the emitter current results in a decrease of voltage between emitter and B1 terminals. Negative resistance property of the device is made use of the relaxation oscillation circuits. Main difference of FET and UJT is that gate surface of FET is much larger than the emitter junction of UJT. FET is normally operated with the gate junction reverse biased, where useful behavior of UJT occurs when the emitter is forward biased. The emitter section is a heavily doped P-type material that is deposited between base B1 and B2, crossing only one PN junction of the small area. What is the advantage of MOSFET? Among this option B is the correct answer. Fast switching speed. The metal oxide semiconductor field effect transistor is a type of FET most commonly fabricated by the controlled oxidation of silicon. It has an insulated gate, the voltage of which determines the conductivity of the device. Primary use is to control conductivity or how much electricity can flow between its source and drain terminals based on the amount of voltage applied to its terminals. Characteristics: 3-terminal device, unipolar, controlled by voltage, high input impedance device. This is the structure of MOSFET. It has one terminal drain, one source and one gate. Gate and channel is insulated by an oxide. Advantages: ability to scale down in size. It is used to work at a greater efficiency but with a lower voltage value, as it has no gate current. So due to this, it gives a high input impedance which produces a high switching speed. Disadvantages: it is susceptible to damage due to its thin oxide layer, which can get damaged because of electrostatic charges. It gets unstable when a voltage gets overloaded. Application: it is used as an inverter, used in digital circuits, used as passive elements like in an inductor, resistor and capacitor. High frequency amplifier, used in brushless DC motor drives, electronic DC relays, SMPS, used as a switch and amplifying signals in an electronic devices. Question number 47. BJT is a current driven device, whereas IGBT is driven by, answer is option C, gate voltage. IGBT is a 3-terminal power semiconductor device, primarily forming and switch. It was developed to combine high efficiency with fast switching. It consists of 4 alternating layers that are controlled by a metal oxide semiconductor gate structure. IGBT has been developed by combining the best qualities of both BJT and power MOSFET. Characteristics of IGBT: high input impedance, low on-state power loss, free from second breakdown problem. Advantages: this is a structure and a symbol of IGBT. Rather than base in the transistor, in IGBT, it is the gate terminal. Advantages of IGBT: lower gate driver requirements, lower switching losses, less size and cost, high efficiency. Applications of IGBT: UPS system, DC and AC motor drives, power supplies and drivers for solenoids and relays. Question number 48. In common collector amplifier circuit, the output is taken from answer is option A, emitter. Emitter follower, also known as collector, common collector amplifier is one of the three basic single stage bipolar junction transistor amplifier topologies. Typically used as a voltage buffer. The emitter follower amplifier presents a high input resistance to signals applied to its base and provides a low resistance effective voltage source at its output. These characters make the emitter follower amplifier well suited for use as a voltage buffer amplifier. The common collector amplifier is also called emitter follower amplifier because the output voltage signal at the emitter is approximately equal to the voltage signal at the input on the base. ഇതാണ് ഒരു കോമൺ കളക്ടർ കോൺഫിഗറേഷൻ. ഇവിടെ കളക്ടർ ടെർമിനലാണ് ഇൻപുട്ടിനും ഔട്ട്പുട്ടിനും കോമൺ ആയിട്ട് എടുത്തിരിക്കുന്നത്. ഇങ്ങനെ എടുക്കാനുള്ള കാരണം എന്താണെന്ന് വെച്ചാൽ നമുക്കറിയാം ഒരു ട്രാൻസിസ്റ്റർ എന്ന് പറയുന്നത് 3 ടെർമിനൽ ഡിവൈസാണ്. പക്ഷേ ഒരു ഇൻപുട്ട് എടുക്കുകയാണെങ്കിൽ അല്ലെങ്കിൽ ഒരു ഇൻപുട്ട് കൊടുക്കുകയാണെങ്കിലും ഒരു ഔട്ട്പുട്ട് എടുക്കുകയാണെങ്കിലും നമുക്ക് 2 ടെർമിനൽ ആവശ്യമുണ്ട്. അതുകൊണ്ട് ഏതെങ്കിലും ഒരു ടെർമിനൽ നമ്മൾ കോമൺ ആയി വയ്ക്കും. അപ്പോൾ ഇതിൻ്റെ ഓരോരോ അപ്ലിക്കേഷന് വേണ്ടി ഓരോരോ കോൺഫിഗറേഷനാണ് നമ്മൾ ഉപയോഗിക്കുക. ഇവിടെ നമ്മൾ ചോദിച്ചിരിക്കുന്നത് കോമൺ കളക്ടറാണ്. അപ്പോൾ കോമൺ കളക്ടർ പറയുമ്പോൾ ഇൻപുട്ട് അപ്ലൈ ചെയ്യുന്നത് ബേസിനും കളക്ടറിനും ഇടയിലാണ്. ഔട്ട്പുട്ട് എടുക്കുന്നത് എമിറ്ററിനും കളക്ടറിനും ഇടയിലാണ്. ഇവിടെ ഇൻപുട്ട് കൊടുക്കുന്ന കോമൺ അല്ലാത്ത ടേം ബേസ് ആയതുകൊണ്ട് ഈ ബേസിനെയാണ് ഇൻപുട്ട് കൊടുക്കാമെന്ന് പറയാം. ഇൻപുട്ട് കൊടുക്കുന്ന ടേമിന് ക്വസ്റ്റ്യൻ വരികയാണെങ്കിൽ ഈ ആണ് എമിറ്ററാണ് ഔട്ട്പുട്ട് എടുക്കുന്ന ടെർമിനൽ. Question number 49. In a cascade amplifier, the gain of first stage A1 is 100, second stage A2 is 20, third stage A3 is 10. The overall gain of answer is option D, 20,000. A multi-stage amplifier is an electronic amplifier consisting of 2 or more single-stage amplifiers connected together. The overall voltage gain is a product of voltage gains of individual stages. That is AV equal to AV1 into AV2, where AV is the overall voltage gain, AV1 is the voltage gain of first stage, AV2 is the voltage gain of second stage. If there are n stages, number of stages, the product of the voltage gains of those n stages will be the overall gain of the multi-stage amplifier circuit. Given AV1 equal to 100, AV2 equal to 20 and AV3 equal to 10. Therefore, overall voltage gain equal to AV1 into AV2 into AV3, that is 100 into 20 into 10, that is 20,000. Note. Here ഈ ക്വസ്റ്റ്യനിൽ നമുക്ക് ഗെയിൻ തന്നിരിക്കുന്നത് നോർമലായിട്ടാണ് ഗെയിന് തന്നിരിക്കുന്നത്. എന്നാൽ ഗെയിന് dB സ്കെയിലിൽ തരികയാണെങ്കിൽ എന്താണ് ചെയ്യേണ്ടത് എന്നാണ് നോക്കേണ്ടത്. ഇഫ് ദ ഗെയിൻ ഓഫ് ഈച്ച് ആംപ്ലിഫയർ സ്റ്റേജ് ഈസ് എക്സ്പ്രസ്ഡ് ഇൻ ഡെസിബിൾസ്, ദ ടോട്ടൽ ഗെയിൻ വിൽ ബി ദ സം ഓഫ് ഗെയിൻസ് ഓഫ് ഇൻഡിവിജ്വൽ സ്റ്റേജസ്. ദാറ്റ് ഈസ് AV dB ഈക്വൽ ടു AV1 dB പ്ലസ് AV2 dB. അങ്ങനെയാണ് വരിക. Question number 50. The theoretical efficiency of class B power amplifier is answer is option B, 78.5%. ഈ ഒരു എഫിഷ്യൻസി ഈ പവർ ആംപ്ലിഫയറുകളുടെ റിപ്പീറ്റഡ് ആയിട്ട് വരുന്നൊരു ക്വസ്റ്റ്യനാണ്. അത് എപ്പോഴും നമ്മളൊന്ന് ഓർത്തിരിക്കേണ്ടതാണ്. ക്ലാസ് ബി പുഷ് ഫുൾ ആംപ്ലിഫയർ എംപ്ലോയ്സ് 2 identical transistors with input signals applied to 2 stages that are 180 degree apart from each other. The transistor to be operated in class B mode kept at the cutoff bias and current in this stage will be equal to 0. The maximum efficiency of class B amplifier is 78.5%. നമുക്ക് വേറെ ആംപ്ലിഫയറുകളുടെയും കൂടെ എഫിഷ്യൻസിയും കണ്ടക്ഷൻ ആംഗിളും കൂടെ ഒന്ന് നോക്കാം. ക്ലാസ് എ പവർ ആംപ്ലിഫയറിൻ്റെ എഫിഷ്യൻസി എന്ന് പറയുന്നത് 25% to 50% ആണ്. കാരണം കണ്ടക്ഷൻ ആംഗിൾ 360 ഡിഗ്രി ആണ്. ഒരു ഇൻപുട്ട് സിഗ്നലിൻ്റെ ഫുൾ സൈക്കിളിലും ക്ലാസ് എ ആംപ്ലിഫയർ വർക്ക് ചെയ്യുന്നതുകൊണ്ടാണ് അതിൻ്റെ എഫിഷ്യൻസി കുറവ്. ക്ലാസ് എ ബി ആംപ്ലിഫയർ എന്ന് പറയുന്നത് ബിലോ 78.5% ആണ്. ബിറ്റ്വീൻ 180 ഡിഗ്രി ആൻഡ് 360 ഡിഗ്രി ഡിപ്പെൻഡിങ് അപ്പോൺ ദ ഓപ്പറേറ്റിംഗ് പോയിൻറ്റ്. അപ്പോൾ 180ക്കും 360ക്കും ഡിഗ്രി ഇടയിലുള്ളത്രയാണ് ട്രാൻസിസ്റ്റർ വർക്കാവുന്നുള്ളൂ. അതുകൊണ്ട് അതിൻ്റെ എഫിഷ്യൻസി വന്ന് 78.5% കുറവാണ്. ക്ലാസ് ബി പുഷ് പുള്ളിന് എഫിഷ്യൻസി 78.5% ആണ്. അതിൻ്റെ കണ്ടക്ഷൻ ആംഗിൾ എന്ന് പറയുന്നത് 180 ഡിഗ്രി മാത്രമേ കണ്ടക്ട് ചെയ്യുള്ളൂ. അതുകൊണ്ടാണ് അതിൻ്റെ എഫിഷ്യൻസി കൂടാൻ കാരണം. ക്ലാസ് സി എന്ന് പറയുന്നത് എഫിഷ്യൻസി എന്ന് പറയുന്നത് 78.5%നും 100% ഇടയിലാണ്. അതിനുള്ള കാരണം കണ്ടക്ഷൻ ആംഗിൾ എന്ന് പറയുന്നത് ലെസ് ദാൻ 180 ഡിഗ്രിയാണ്. ഇത് കമ്പയർ ചെയ്യുമ്പോൾ ക്ലാസ് സിയിൽ കണ്ടക്ഷൻ ആംഗിൾ കുറവായതുകൊണ്ട് എഫിഷ്യൻസി കൂടുതലാണ്. ഇതാണ് തമ്മിലുള്ളൊരു റിലേഷൻ. ഈ വാല്യൂസൊക്കെ ഒന്ന് ബൈ ഹാർട്ട് ചെയ്തിരിക്കണേ. Question number 51. What is the first stage of op-amp in block diagram? Answer is option D, differential amplifier. An operational amplifier, op-amp is an integrated circuit IC that amplifies the difference in voltage between two inputs. It is so named because it was developed for perform arithmetic operation, amplifiers, buffers, comparators, filters, etc. IC741 is the most commonly used op-amp. This is the block diagram of an op-amp. First block is input stage, second is intermediate stage, third is level shifting circuit, and fourth one is the output amplifier. Input stage, it is dual input balanced output differential amplifier. It reject noise, provide high input impedance and provide high voltage gain. Next one is the intermediate stage, dual input unbalanced output amplifier, provide high voltage gain. Next one is the level shifting circuit, that is buffer and level shifting circuit. Use emitter follower circuit, high input resistance and low output resistance, avoiding loading effect, set DC level to 0. The final stage is output stage. It is a complementary push-pull amplifier. It decreases output impedance and increases output voltage swing. ഒരു നോട്ടുണ്ട്, ക്യാരക്ടറിസ്റ്റിക്സ് ഓഫ് ഐഡിയൽ ഓപ്പ്-ആമ്പ്. ഐഡിയൽ ഓപ്പ്-ആമ്പിനെ ഇതൊക്കെ ബൈഹാർട്ട് ചെയ്തതിൻ്റെ ഇമ്പോർട്ടൻ്റ് ആയൊരു കാര്യമാണിത്. ക്യാരക്ടറിസ്റ്റിക്സ് ഓഫ് ഐഡിയൽ ഓപ്പ്-ആമ്പ്: ഇൻഫൈനൈറ്റ് ഓപ്പൺ ലൂപ്പ് ഗെയിന്, ഇൻഫൈനൈറ്റ് ഇൻപുട്ട് ഇംപിഡൻസ് ആർ ഇൻ ആൻഡ് സോ സീറോ ഇൻപുട്ട് കറണ്ട്, zero input offset voltage, infinite output voltage range, infinite bandwidth, infinite slew rate, zero output impedance R out, and so infinite output current range, zero noise, infinite common mode rejection ratio, infinite power supply rejection ratio. Question number 52. The ratio of differential voltage gain AD to the common voltage gain ACM in op-amp is, answer is option C, CMRR. What is CMRR? CMRR is a measure of the capability of an op-amp to reject a signal that is common to both inputs. The CMRR of an op-amp is the ratio of differential voltage gain to common mode voltage gain. Slew rate is defined as the maximum rate of change of an op-amp's output voltage and is given in units of volts per microsecond. Supply voltage rejection ratio determines how much noise from the input couples into the output. It is also called a power supply rejection ratio. Unit of power supply rejection ratio or supply voltage rejection ratio is in microvolts per second or decibels. Thank you.